Hello everyone, welcome to the lesson of functions of several variables. Today we will discuss some examples and questions based on functions of several variables. This is the question: let z equals 2x plus iota y, where function from R2 to R2 be given by z square equals to x square minus y square 2xy belongs to R2 space. Let dfa denote the derivative of f at point E. Choose the correct option. These are our options. 1, 2, 3, 4. These are options we have to select. So let us calculate. Let us assume f1 equals to x square minus y square and f2 equals to 2xy. According to given options, first of all we will calculate del f1 del x, del f1 del y accordingly, because f1 is x square minus y square, f2 is 2xy. So del f1 del x is 2x, similarly minus 2y, and etc. Now we are working in two space R2, therefore let us consider also given this one. So let us assume or writing this one in two space in bracket form as this one. E equals to A1 E2. Here A1 is the x and A2 is the point of y. So we can say A1 is x coordinate, A2 is y coordinate. On putting or substituting all the values here, we will obtain this one. Accordingly, our option 2 is correct. Out of these options, this option is correct. Now let us see option 1. So dfah, we have to calculate in option 1 dfah, where h is this one given, a is given here. After calculation dfah, h1 h2 according to our matrix multiplication, we are obtaining this one. After calculation, we will see that this option 1 also true. Now first is true, second is true. Now let us see about 3 and 4. So from dfz we have calculated, that is 2x minus 2y and 2y 2x. According to options, firstly we will determine the determinant of this df. So determinant of this one is 4x square plus y square, which will not be 0 if xy will not be 0. And this one, this determinant, this value will be 0 if x and y both will be 0. Therefore, our option 3, f is 1 1 on R2 is not correct, because determinant is 0 at point this one. Now let us check our last option, that is for any a belongs to this one is 1 1 in some neighborhood of a. Now let us check. So determinant will not be 0 if this condition holds true. As we know that f is invertible if this determinant is not 0. Therefore f is invertible. That means in this condition R2 minus 0 0. F is 1 1 in some neighborhood of A because f is invertible. F is determinant is not 0. Therefore option 4 is true. Now let us consider partial derivatives of a function of more than one variable, function containing x, y and so many variables with respect to variable x. So let us see here partial derivative of a function more than one variable is here, function of x, y, z, etc. with respect to the variable x is represented by any of the symbol. And generally we are using this del f del x. So this is the definition. Let D be an open subset of Rn. Function D to R be a function. Let us consider for our simplicity n equals to 2. Therefore, let us consider A and B be any point of this open subset of R2. Now we are considering this question. Consider function from R2 to R defined by this one. Let us find both the partial derivative of f at point 0 0 exist. And secondly, we have to obtain directional derivative of function at point 0 0. So this is the basic definition we have seen. Again, we are writing this one here, del f del x limit definition of partial derivative. So this is the limit definition of partial derivative del f del x at point AB, limit s tends to 0, function of e plus h comma b minus fab upon h. Because this function we have partial derivative with respect to x. Therefore, there is a simple change in x. Similarly, with respect to y, derivative, partial derivative with respect to y is here. Now this is given a problem, fxy is this one. We want to obtain partial derivative with respect to x at point 0 0. On applying limit, calculation gives us 0. This exists. If 0 is here, limiting value or finite value is here, we can say partial derivative at point 0 0 exists. Similarly, partial derivative with respect to y at point 0 0. It becomes 0. We can say 0 k on 0 plus k square. So this gives us 0. So partial derivative, both we can say both the partial derivatives of function with respect to x and with respect to y exist. Now we want to obtain directional derivative. So this is the basic definition of directional derivative. Here f be a real valued function and D is an open subset of R2 and C be any point. Let us consider U1, U2 be the 2 point in R2 space. Therefore, directional derivative in the direction of U is given by this one. So on putting all the value, because we want to obtain directional derivative at point 0, 0. So C is 0, 0. U, we are considering here even, we are considering here this is E1 and E2 according to our situation. So H E1 E2 minus F0, 0 C, we want to obtain directional derivative at point C. So calculation gives us this one. After simplification, we are obtaining E1 square upon E2 upon this one. Now, here we have two cases. If E1 is 0, E2 is 1, limit exists. E1 is 1, E2 is 0, limit exists. So we can say that directional derivatives exist in any direction of U. Now these are the practice questions. If function of xy equals to this one, we have to obtain partial derivative with respect to x and y at point 0, 0. Answer will be 1. Second question is this one. We have to check the continuity at point 0, 0. So answer is continuous at 0, 0. One can solve easily these problems. If facing problem, may discuss with us. If want to further notification, you can subscribe. Thanks for watching.